Hey guys, welcome to lesson 4.4. Today we're talking about factoring quadratic expressions, everybody's personal fave. Woo, we're gonna factor, so much fun. Listen, I know that you guys don't like factoring, but factoring is one of those topics that we gotta get down, right? Factoring is something that you will use from this class beyond. You learned how to do it in Algebra 1. We're going to continue to learn how to do it in Algebra 2, and you are going to use what you know about factoring in every single math class that you take from now on, okay? So it's very important that you understand how to factor. Listen, we're going to make mistakes, all right? Sometimes it's going to be difficult. There are going to be problems that take a while, but once you learn how to factor, it's an acquired skill, right? You learn how to factor, it becomes natural the more you practice, and you become better at it. So what I encourage you to do is use this video as a tool to help you get better with factoring. So please, if you need to pause the video to think about something, go ahead and pause the video. If you need to rewind because you don't understand where a step I was getting came from, go ahead and rewind the video, but use this as a tool to get better at factoring so you can be successful in your other math classes and in my class. So let's go ahead and get started. First of all, what is the definition of factoring? Well, I know that factoring is the process used to rewrite an expression as the product of its factors. The common factor of each term of an expression that has the greatest coefficient and the greatest exponent is called the GCF, or in other words, the greatest common factor. So if we're looking more specifically at the greatest common factor, for example, the GCF of 4x cubed plus 20x squared minus 12x, if we're looking for the greatest common factor of some expression, we are looking for the largest term that can be divided out of each and every term in the expression, okay? So we're thinking to ourselves two things. First of all, what is the greatest coefficient that I can divide out of each of these numbers, okay? So looking at my coefficients, I have 4, 20, and negative 12. So what is the largest number that I can divide out of each of those three terms? Well, I notice that I have a 4 right here, so obviously I can't go above 4, as no numbers greater than 4 are going to divide out of 4. But I do notice that 4 goes into 20, and it also goes into negative 12. All of those numbers are divisible by 4. So what that's telling me is that my coefficient for my GCF is going to be 4. Now I need to think to myself, what is the largest exponent of the variable that I can pull out of each of these terms? Well, if I take a look here, I have x cubed, x squared, and x. And since x, obviously, I can't go above x because any exponent higher than 1 is not going to allow me to pull out of x. So the greatest exponent that can be pulled out of all three of those exponents is just going to be x to the first power, okay? So 4x is going to be my greatest common factor. That's the biggest thing that I can divide out of each of those terms. Kind of shifting gears a little bit, a trinomial that is the square of a binomial is known as a perfect square. And that is known as perfect square trinomial. 25x squared minus 30x plus 9 is equal to 5x minus 3. That is represented by a perfect square trinomial, okay? While an expression of the form a squared minus b squared is known as the difference of two squares. Okay, and that can be factored as a plus b times a minus b. So an example of the difference of two squares, if we had 36x squared minus 25, the way we know if something is a difference of two squares, if both terms are able to be square rooted, okay, if they are both perfect squares, you're able to take the square root of them and you get something clean. That tells you that we're going to have a difference of two squares if you're subtracting those two things from each other. And we can actually take the square root of each of those terms, figure out what a and b are, and rewrite it as a plus b times a minus b. So for example, if we were to take the square root of 36x squared and 25, that would be 6x and 5. So then what I can do is I can use the rule a plus b times a minus b to write 6x plus 5 times 6x minus 5. Last but not least, let's talk about foiling real quick. So foiling is just something that we use to help us remember using the distributive property if we're multiplying two factors together or two binomials together. So what this stands for, once again, you remember this from Algebra 1, but this means first, and then outer, and then inner, and last. Okay, so just a quick review of Algebra 1. That is how we use foiling. If we're multiplying two binomials together, you can use first, outer, inner, last to multiply the terms together and then get something that's a little bit less condensed. Okay, let's move down to actually how to factor. So the first type of factoring we're going to look at today, we're going to look at factoring ax squared plus bx plus c if a is positive or negative 1. So the only way that the steps that I'm going to show you are going to work is if a is positive or negative 1. If a is anything other than positive or negative 1, we're not going to be able to use this method. We're going to have to use a different method, and I'll show you that method a little bit later on. But what we're going to do is we're going to look at examples that specifically just have leading coefficients that are positive or negative 1. So the procedure for this process, the first step we are going to use, we are going to find factors of the constant c. Okay, so if you remember back from when we were talking about some of the terms and stuff of an expression earlier in this unit, keep in mind that c is going to be that last term. It's the term that doesn't have a variable attached to it. It's just a constant. So we're going to be finding factors of the constant. Then the second step, we are going to find two factors of c whose sum is the constant b, okay? So we're going to be looking for factors of c that add up to or sum to b, that middle term inside of an expression. And then last but not least, we're going to write the trinomial as a product of two binomials once we figure out what the factors are. Okay, so let's look at example number 1. We have x squared plus 14x plus 40, and we have to factor this. So the first thing I want to do is I'm going to follow that first step. I'm going to find the factors of the constant c. So again, I'm looking for factors of 40, the last term in my expression. So what are some factors of 40? Well, I know that some factors of 40 are going to be 1 and 40, because 1 times 40 is 40. Some other factors of 40, I might have 2 and 20. I might have 4 and 10, maybe 8 and 5. So I'm just kind of compiling a list of all of the factors I know that give me a product of 40. So these are just a good list of factors. And so once you get a good list of factors, now we're going to actually go through and see what the sums of these factors are. So again, I'm looking for factors of 40 that are going to sum up to b. Okay, so I'm looking for factors of 40 that sum up to 14. Okay, so what are some factors of c that sum to b? Let's take a look. So if I add these numbers together, 40 plus 1 is just going to give me 41. Well, obviously, I know that 41 is not equal to 14, so that's not going to be the correct one. 2 plus 20 is going to give me 22, so I know that that is not going to be the correct one because they do not add up to 14, or my b term. But I do realize that 4 plus 10 gives me 14. So, oh, hey, this is the one I need. Okay, so once I find two factors that add up to that b term, those are the factors that I'm going to use to create my product of binomials. So what this is saying is basically, if I were to draw the diamond method, I'm not sure what method you guys use to learn how to factor, but basically what we're saying here is if you are trying to find factors of 40 or that a times c value, right? Because we're looking right here at the c value. Since a is 1, a times c is always just going to be the c value for these examples. But we're looking for factors of 40 that add up to that 14 value. So the factors that worked here were 10 and 4, okay? Because once again, if we take 10 times 4, that gives us 40. And if we take 10 plus 4, that gives us 14. So those are the factors we want. And if we're going to write that down as a product of two binomials, I'm going to write that down as x plus 10 times x plus 4. Okay, so once again, we are getting these numbers from the factors that I found, and now I'm plugging them in to my binomials. And that is going to be my answer, x plus 4 times x plus 10. All right, so let's go ahead and look at part B. So we have x squared minus 11x plus 30. First of all, I want to look for the factors of c And then I'm going to figure out what their sum is, and I have to find the factors that have the sum of b. Remember, c in this case is equal to 30, so I have to find factors of 30, and b is equal to negative 11, so I have to find factors that add up to negative 11. Okay, so let's go ahead and take a look at some of the factors of 30. Now, one of the things that I want you to recognize is that our sum needs to be a negative number. Now, obviously, two positive numbers added together is not going to give you a negative number, so we need to look at negative factors. So I'm just going to be careful here. Because my sign is negative, all right, because my sign is negative, I have to look at negative factors. So just be careful. Okay, so what are some negative factors of 30? Well, I know that negative 1 times negative 30 are some negative factors of 30. If we add negative 1 plus negative 30, so negative 1 minus 30, that gives me negative 31. So that's not what I need because I don't have negative 11. So I'm going to move on. Then I have negative 3 times negative 10. That's going to give me 30. Negative 3 minus 10, that gives me negative 13. Still not where I need to be. And then if I take negative 6 times negative 5, that's going to give me 30. And then negative 6 minus 5, oh, hey, that turns into negative 11. That is exactly, I'm going to make that a different color. That is exactly the one that we are looking for, okay? Because those factors, they multiply to 30, and they add up to negative 11. That's exactly what I need. So if I go ahead and put my diamond down here, 30 goes on top. Remember, we always put that C value on top. I always put A times C just so that when we get to the other stuff, it doesn't get complicated. But A times C goes on top, and then B goes on the bottom. So negative 11 down here. Factors of 30 that add up to negative 11. Well, I found that negative 6 times negative 5 multiply to 30, and they also add up to negative 11. So those two numbers are going to be the factors of my expression. So once again, I'm going to write these in my binomials here. So I have x, and I'm literally just going to drag and drop those factors into my expression. So I'm going to say x minus 6 times x minus 5. So those are the two factors of this expression. All right, part C, we have x squared plus 4x plus 21. Let's look at some of the factors. So again, we're looking at the factors of C, which is 21 here. I can make that a different color. Oh my goodness. All right, so we are looking for the factors of C that add up to B. Okay, I know that C is equal to 21 in this case, and B is equal to 4 in this case. So factors of 21 that add up to 4. Okay, so I know that some factors of 21, I have 1 times 21. 1 plus 21, oof, that gives me 22, nowhere even close. And then 21, also I have 3 times 7, that multiplies to 21. 3 plus 7 is going to give me 11. Oh, shoot. Oh, my goodness. Do I have any more factors of 21? I can't think of any. 21's not divisible by 2, anything like that. So, you guys, if we come to a situation like this where you're like, oh my gosh, I'm trying to figure this out. Factors of 21 that add up to 4. Okay, I don't know what I'm doing. If you can't find any factors, what that means is your expression is prime. It cannot be factored, okay? So if you're literally sitting there and you're like, oh my God, I've tried everything. There is no numbers that are going to give me a factor of 21 and a sum of 4. That means you don't need to factor it. It's prime. It can't be factored, okay? So we're going to just leave it as is. All right, part D, 36 plus 5x minus x squared. Oh, be careful. Be careful. This is all out of order, okay? If you try to start doing things with this, it's not going to work because you're going to be thinking, oh, well, this is A, this is B, this is C. Incorrect. Our highest exponent needs to be first in order to follow that order. So I'm going to order some things around here. I'm going to put negative x squared first. Then I'm going to put positive 5x in the middle. And then I'm going to put plus 36 at the end. Now, I have a negative number on the outside. So, oh my goodness, I don't like negatives on the outside because that's going to mess up my factors. So what I'm going to do here, because I have a negative, I'm going to factor out the negative 1. Okay, I'm going to make this positive 1 on the front. So if I factor out a negative 1, here's what's going to happen. We have negative x squared divided by negative 1. That's positive x squared. Positive 5x divided by negative 1 is negative 5x. And then positive 36 divided by negative 1 is negative 36. So now I have negative times x squared minus 5x minus 36. So now I have my A, I have my B, and I have my C. So we're all good to go. All right, so I'm looking for my factors of C that are going to add up to B. So some factors of C, negative 36. I have, let me think here. I have, I can mess around with the order, right? So negative 36, I might have 1 times negative 36. The sum of that is going to give me negative 35, which is nowhere near close enough to that number. I can also do 2 and negative 18. 2 times negative 18 is negative 36. And then 2 minus 18 is negative 16. Oy, I'm going to keep going. 3 and negative 12. 3 times negative 12 is negative 36. And the sum of that is going to be negative 9. Still not there. But 4 times negative 9, oh my goodness, 4 times negative 9 is negative 36. And 4 minus 9, oh, would you look at that? Gives me negative 5, which is my B value. Excellent. That's exactly what I want. So the factors that I'm looking at are 4 and negative 9. So what I am saying here is factors of negative 36 that add up to negative 5, okay? Those are going to give me 4 and negative 9. So I'm going to plug those in. You got to be careful here, though, because it's very easy to drop this negative. We have to keep that negative out front. So I'm going to have negative, then my two binomials, x plus 4, x minus 9. Once again, we are dragging and dropping these factors into my binomials. And that is how we factor, ladies and gentlemen. All right, let's move on to the next page. So next page, finding common factors. We're going to find the GCF of all of these, and then we're going to factor first, okay? So this adds an additional step. If we have a number that is not 1 on the outside, the first thing you're going to check and see is, can I factor out a GCF? Okay, so can I pull out a GCF? And if I can, that's going to make my life a little bit easier. So let's look at part A. We have 7n squared and negative 21. Is there something that can be divided out of both 7n squared and negative 21? Well, first of all, I know that 21 does not have a variable, so I can't factor out a variable. So n is not going to be part of my GCF, but I do know that 7 goes into both 7 and 21. I can pull 7 out of 21, right? So my GCF here is going to be 7. That is the largest thing that I can pull out of both of those terms. So if I pull a 7 out of this binomial, I'm first going to write 7 out front, and then parentheses. 7n squared divided by 7 is just going to be n squared. And then negative 21 divided by 7 is going to be negative 3. So I have 7 times n squared minus 3, and that is going to be my GCF. So if I'm factoring out the GCF, making my life a little bit easier. Part B, I have 9x squared plus 9x minus 18. All right, well, here's the deal. Can I pull something out of all three of those terms? I notice that I have a 9 here, a 9 here, and a negative 18 here. Is there something that I can pull out of all three of those terms? Well, yeah, I know that 9, 9, and negative 18 are all divisible by 9, so I can pull out a 9. And if I pull out a 9, 9x squared divided by 9 is x squared. 9x divided by 9 is plus x. Negative 18 divided by 9 is negative 2. Now, I still have a trinomial, so I'm going to try to factor this. So let's go ahead and use the diamond method here. So if I'm using the diamond method, I'm going to put C on the top. So C is going to go up top. Then I'm going to put B on the bottom here, and I'm going to write that down. So once again, we have on the top A times C. On the bottom, we have B. So I'm going to put C as negative 2 in this case. Okay, because again, I was accidentally doing this earlier. Yeah, we're not looking at that right now. That was a mistake. My bad. Sorry. We're just looking here because we're trying to factor this expression now. So now that I already factored out a GCF, I'm trying to factor x squared plus x minus 2. And that's it. So I'm going to put negative 2 on the top because that's A times C. And then I'm going to put B on the bottom, which is just going to be 1. So factors of -2 that add up to 1. Let's think about this. So some factors of -2. Well, I can have 1 times -2. 1 times -2 is going to give me -1 if I add those two together. I can also do -2 times 1, right? But unfortunately, that is also going to give me a -1. What if I did 2 times -1? If I did 2 times -1, I know that 2 times -1 equals -2, and then 2 plus -1 is equal to 2 minus 1, which is equal to 1. So, hey, factors of -2 that add up to 1 are going to be 2 and -1. All right? So now I have my factors that fit my criteria here. I'm going to put those inside of my parentheses and put this in factored form. So once again, since we have a 9 out front, we have to keep the 9. So I'm going to put a 9 out front here. Then I have x and x. I'm creating 2 binomials. And I'm going to drop my factors in, x plus 2, x minus 1. So my answer is 9 times x plus 2 times x minus 1. Part C, 4x squared plus 8x plus 12. First things first, let's look for a GCF. What is the largest thing I can pull out of all three of those? I notice I have a 4, an 8, and a 12. Well, I know that 4 goes into all three of those, so my GCF is going to be 4. So if I pull a 4 out, I'm going to have 4 out front. 4x squared divided by 4 is just going to be x squared. 8x divided by 4 is going to be plus 2x. And then 12 divided by 4 is going to be plus 3. So now that I have this factored a little bit more, I'm going to look at this inside parentheses stuff, and I'm going to try to factor that down even more. So on the top, I'm going to have a times c. On the bottom, I'm going to have b. And I know right here, a times c is 3. So I'm going to put 3 on the top. And then b is on the bottom here, 2. So I'm going to put 2 down here. So I'm looking for factors of 3 that add up to 2. Oh. Do I have any factors of 3 that add up to 2? Well, I know that I have some factors here. I have maybe 1 times 3, but the sum of that is going to be 4. I maybe have, that's it. So once again, this is one of those cases where you're like, I can't find anything. This is bad. All that's telling you is that this is prime. You can't factor it anymore. So once I have gotten down to this, I can stop because the rest of it's prime. I can't factor that out anymore, okay? So if you can't factor it out anymore, just leave it as is. Now we have 4 times x squared plus 2x plus 3. Looks a little cleaner than at the start, but obviously we can't take it down any farther. Part D, 18y squared plus 9y minus 27. So here's the deal. I'm first going to look for my GCF. What is my GCF of 18, 9, and negative 27? Something that I can pull out of all three of those. Well, I know that all three of those are divisible by 9. So my GCF here is going to be 9. That's it. So I'm going to pull out a 9. 18y squared divided by 9 is going to give me 2y squared. Okay. 9y divided by 9 is going to give me just plus y. And then negative 27 divided by 9 is going to give me negative 3. Okay. Here's the deal. So now, obviously, we have a coefficient that is greater than 1. You're like, oh, no. Okay, this is crazy. No need to panic. I'm going to show you how to do it. So what I would like you to do is off to the side, you're still going to put your diamond just like this, okay? First thing that goes on top of the diamond is going to be a times c. This is why I told you, very important to think of the top as a times c. The bottom is b. So a times c is going to be 2 times negative 3. So I'm going to put a negative 6 on the top, okay? Then on the bottom, I'm going to put b. b is going to be 1, so I put 1 on the bottom. So now I'm looking for factors of negative 6 that add up to 1. Well, some factors of negative 6, I might have, let's think here, negative 2 times 3. Negative 2 times 3 gives me negative 6. And hey, if I add negative 2 plus 3, if I add those together, that's going to give me positive 1. So those are the factors I'm looking for. So negative 2 and positive 3 are my two factors. So here's the one thing that's going to be a little funky that I need you to pay attention to. If your leading coefficient is not 1, I'm going to put a little star right here, okay? Lead co does not equal 1. What we are going to have to do is we are going to take the number that I already have outside. I'm still going to keep that number. But then I'm going to have to pull out a fraction, and the denominator of my fraction is going to be whatever this leading coefficient is. So if my leading coefficient is a 2, I am going to pull out a 1 over 2. Okay, and we're going to see how this works in just a second. So now we are going to write our factors down. Our factors for this were -2 and +3. Okay, now another thing that's a little bit weird if our leading coefficient is not 1 is instead of just putting y here, I'm going to have to put 2y here because again, I have a 2y squared. So instead of just putting y, I'm going to put 2y. Okay, so I have 2y minus 2 times 2y plus 3. So again, I am dragging and dropping those factors inside of my binomial. And because my leading coefficient was not 1, I had to drop down the 2 y's, okay? Now, the very last step, just to clean this up a little bit, I'm going to figure out where I can multiply 1/2 to make it even cleaner. So let's think about this. If I were to multiply 1/2 to these terms inside of that binomial, what's going to happen is 1/2 times 2y is just y. 1/2 times -2 is -1. So that's going to be even cleaner, and then I don't have to worry about this fraction being here. So what I'm going to do is I'm going to distribute this inside of my parentheses, and then this is going to simplify to 9 times 1/2 times 2y is y, 1/2 times -2 is -1, and then I have 2y plus 3 on the right-hand side. So I have 9 times y minus 1 times 2y plus 3. And that is the answer to this question. And that's going to lead us into example number 3. Example number 3, we are going to find the factors of AC equals B, and then we are going to factor completely, okay? So same thing we did in the last one. Let's just go ahead and do it first. So first thing I'm looking for, can I pull out a GCF? No, if I'm looking at this, none of these numbers are going to be divisible by something that's in common. So I'm going to move on, and I'm just going to go straight into factoring. So let's go ahead and put down our diamond. As I said before, the top is always going to be A times C. The bottom is going to be B. So we're going to put A times C on the top of my diamond. A times C is 4 times 3. 4 times 3 is 12. B is going to be that middle term, 7. So I put 7 on the bottom. So factors of 12, so numbers that multiply to 12, but add up to 7, okay? So what are some factors of 12? Well, I know that I have 3 times 4. If I put 3 and 4 in here, 3 times 4 is going to give me 12. And then 3 plus 4 is going to give me 7. So that is exactly what I want to happen. Okay, so like I said, the funky thing that you have to do if your leading coefficient is greater than 1, we are going to have to write down first a fraction with that leading coefficient in the denominator. So I'm going to put 1/4 down here. Then I'm going to put my little factors right here. I know that my factors are going to have 4x instead of just x, because again, that leading coefficient is different than 1, so I have to put down 4x. And then I'm going to drop my factors in, plus 3, plus 4. The last thing that I can do is I want to figure out which one of these binomials can I multiply this 1/4 into to make it cleaner. Well, hey, if I multiply this 1/4 all the way over here into this binomial, 1/4 times 4 is just 1. 1/4 times 4 is just 1. So that's going to clean it up a little bit. Then we can get rid of the fraction, because I don't like fractions. So I'm going to have to take this 1/4, multiply it into those two terms. Remember, I'm only multiplying it into one of the binomials, not both of them. So this is going to turn into 4x plus 3 on the left-hand side. 1/4 times 4x is just x. 1/4 times 4 is just 1. So my factors are 4x plus 3 times x plus 1. All right, next up, 2x squared minus 7x plus 6. First thing I want to do is I want to put my diamond down. A times c goes on the top, b goes on the bottom. A times c is 2 times 6, which is 12. B is the middle term, which is -7. Factors of 12 that add up to -7. Well, once again, we have a negative b term. So what that means is, hey, I'm going to have to look at negative factors. because obviously the sum of those has to be negative, so I'm going to look at the negative factors. So let's go ahead and look at these. If I do -3 times -4, obviously if you multiply those together, that's going to give you 12. If you add those together, that's going to give you -7. Okay, so those are the factors we're looking at. Just go down the list. So if you're like, okay, -2 times -6, that adds up to -8, so that's not right. You just got to go down the list and try to find the ones that work. All right, so once again, since we have a leading coefficient that's not equal to 1, we're going to have to drop this down and put the fraction 1/2. So we put that leading coefficient in the denominator. Then my factors are going to have the same number in front of the x. So I have 2x and 2x. And then I'm going to drag and drop my factors into my binomials. So I have -3 and -4. Now I want to clean this up a little bit. So which of these can 1/2 multiply into? Can it multiply into these? Or does it have to multiply into those? Which one is going to be cleaner? Well, obviously I can multiply 1/2 times 2 and 1/2 times -4. So that's going to get rid of my fraction. So I'm going to go ahead and do that. So 1/2 times 2 and 1/2 times -4, this is going to turn into 2x minus 3 times 1/2 times 2x is just x. 1/2 times -4 is -2. And that is the answer to my question. All right, last but not least, we have 3x squared minus 8x plus 4. First things first, I have to look and see a times c. That's going to be 3 times 4 is 12. Lots of 12s today. And then b is -8. So what are some factors of 12 that add up to -8? Once again, because that number is negative, we are going to have to look at the negative factors. All right, so some negative factors of 12. We have -3 times -4, but that only adds up to -7. But what about -2 times -6? That's going to multiply to 12, and that's also going to add up to -8. So I'm going to go ahead and put -2 and -6 in. Once again, they multiply to 12, and then they add up to -8. So we're exactly where we need to be. Okay. Once again, this right here, leading coefficient is different than 1, so I have to put 1/3 out front. Then I'm going to put that 3 in the front of my x's inside of my binomials. And then last but not least, I'm going to drag and drop my factors in. So this is 3x minus 2, 3x minus 6. Which one of these can I multiply this 1/3 into to get rid of it? I don't want fractions. I can multiply that into the second term, or the second binomial, excuse me, because that's going to be 1/3 times 3 and 1/3 times -6. So this comes out to 3x minus 2 times, if I multiply this one into that second binomial, 1/3 times 3x is just x. 1/3 times -6 is -2. So the answer is going to be 3x minus 2 times x minus 2. And that is how you factor when your leading coefficient is not 1. All right, we're going to look at a couple more cases and then we're going to call it a day. So we got some special cases that I want you to look at. So a special case that we're going to look at first of all is going to be factoring a perfect square trinomial. Now, a perfect square trinomial, here's how you can figure out if something is a perfect square trinomial. The first thing you're going to notice is that A and B, or your outside ends of the expression, so the ends right here, ends are perfect squares. Okay, that's the first thing that you're going to notice. The ends are perfect squares. The second thing you're going to notice is that the middle is going to be the first times the second times 2. Okay, so the middle is going to either be -2 times AB, so the two ends, or 2 times AB. Okay, so no matter what the sign is, if you have double AB in the middle and the ends are perfect squares, that tells you that you are dealing with a perfect square trinomial. And we have a rule for this that's going to make your life a little easier when factoring. So the rule for a squared plus 2ab plus b squared, we can write that as a plus b squared. So we can figure out what a and b are and simply factor it to a plus b squared. Notice how if I have a plus sign in front of that 2ab, I'm going to have a plus sign inside of my factor, okay? A squared minus 2ab plus b squared, similarly, but this is going to be a minus b squared. That's the rule we're going to follow. Notice once again that if we have a minus out front of here, we have a minus inside of our factor. So let's go ahead and look at an example. Example number 4, 25x squared minus 20x plus 4. All right, first things first, I noticed that I have a negative, so I'm going to probably be using this second formula over here, okay? So if I take a look here, oh my goodness, the ends are perfect squares, right? Because I can take the square root of 25x squared. I can also take the square root of 4, and they come out to clean numbers. So the ends are perfect squares. So what we're looking at here is if I took the square root of 25x squared, what I'm really doing is I'm taking 5x and I'm squaring it. That is the equivalent to 25x squared. And then I have minus 20x, and then I'm adding, well, I know that 4 is 2 squared, so I can replace that with 2 squared. So essentially, I'm just replacing it with whatever its square root is. So I'm breaking it down a little bit more. And the reason I'm doing this is because now I can realize that I have a pattern, all right? This is A. 5x is equal to A, right? Because A squared, if A is equal to 5x, A squared would be equal to 25x squared. This is B, because if B were 2, 2 squared is 4, and that follows the formula that we need. Okay, so now that I know what A and B are, I can simply plug them into this formula. Okay, so I know that A is equal to 5x. I know that B is equal to 2. So if I plug that into the formula up there, I'm going to have A minus B squared, which is just 5x minus 2 squared. Okay, so figure out what A and B are, plug it into the formula. Part B, 64x squared minus 16x plus 1. Okay, we're going to figure out, first of all, if we're looking at a perfect square trinomial. So I notice that my ends are perfect squares, 64x squared. If you take the square root of that, you're going to get A equals 64x squared. The square root of that is going to be 8x. And then also, if we take the square root of the last term, we know that B over here is going to be equal to 1. The square root of 1 is just 1. And if I multiply 2 times that, or negative 2 times that in this case, that's going to be negative 2 times 8x plus 1, which is negative 16x, which is our middle term. So this is a perfect square trinomial. So now that I know this is a perfect square trinomial, and I figured out what A and B are, since this is negative, I'm going to plug these A and B's into that second formula. So this is going to turn into A minus B squared, which is the same as 8x minus 1 squared. Last but not least, we have 4x squared plus 28x plus 49. The ends are perfect squares, and the middle will multiply to the A and B times positive 2. What I want you to recognize here is that we have a positive, so that means we're going to be using the first formula, okay? And then I'm going to figure out what A and B are. So if I take the square root of 4x squared, I know that A is equal to 2x. Then if I take the square root of 49, I know that B is equal to 7. So I can plug those into that first formula because, again, I have a positive. So this is going to turn into 2x plus 7 squared. All right. Moving down, what if we're factoring a difference of 2 squares? So if we have something that follows the formula of A squared minus B squared, we can rewrite that using this rule. A plus B times A minus B. Okay, so first things first, we have to figure out what A and B are. The way you know if you are dealing with a difference of squares is if your two terms are perfect squares. And also, obviously, you are taking the difference of them. Okay, so you have to be careful. Make sure that you have a negative. If you don't have a negative in between, we cannot use this rule. The difference of 2 squares means that we are literally taking the difference of 2 perfect squares. Okay, so number 5, we have A, 16x squared minus 81. I can see if these are perfect squares because if I take the square root of them, they better be clean. But I know that the square root of 16x squared, that is just going to be, I'm going to write this as A equals. So if I take the square root of that A squared term, I know that A equals 4x because the square root of 16x squared is just 4x. And then if I take the square root of 81, I know that B is going to be equal to 9, okay? Because the square root of 81 is 9. So now I know that those are perfect squares because they come out clean. I can plug these into this rule right here. So A plus B times A minus B. I have 4x plus 9 times 4x minus 9. okay? You can always check yourself to make sure you got it right by refoiling. If you refoil this, you will get the original expression, 16x squared minus 81. And that goes for any of the factors that we do today. If you refoil them out, you will get the original answer. And if you don't get the original answer, that means you did something wrong. You have to go back and check. All right, part B, 25x squared minus 36. First thing I want to do is I want to figure out what my a and b terms are because I'm trying to see if this follows a squared minus b squared. So if I take the square root of this, I know that a is going to be equal to 5x because the square root of 25x squared is just 5x. And then b, if I take the square root of 36, is going to equal 6. So now that I know what a and b are, I can plug them into this formula. So I'm going to have 5x plus 6 times 5x minus 6. That's a plus b times a minus b. All right, going down to part C, I have 9m to the fourth minus 1. First of all, we're going to see if this follows the a squared minus b squared form. So if I take the square root of those, they better be clean. If they are not, then they're not the difference of two squares. But the square root of 9m to the fourth, well, we know that if we have m times m times m times m, if we're taking the square root of that, we're looking for doubles. So I have a double here, and I have a double here. So the square root of m squared is just going to be m times m, which is m squared, or excuse me, the square root of m to the fourth is going to be m squared, okay? So if I take the square root of 9m to the fourth, that's going to be 3m. The square root of m to the fourth we said is m squared. So I know that a equals 3m squared, and the square root of 1 is going to be b equals 1. So now I can plug those into the formula. I have 3m squared plus 1 times 3m squared minus 1. And that is how you would factor. Once again, you can refoil it to double check your work, but that's the difference of squares, so we're going to plug it into the formula. Last but not least, I have 36x squared plus 9. Oh no. What am I looking at here? I'm looking at the sum of two squares. Now, is this formula the sum of two squares or is it the difference of two squares? We don't have a difference here, so we can't exactly use this formula. But what we can do is we can factor out a GCF, right? So my GCF here, something that I can pull out of both of these, I know I can pull a 9 out of both of these. So if I pull a 9 out of both of these, this is going to be 9 times 36 divided by 9 is 4x squared plus 1, and I can't do anything else with this, you guys, because this is not able to be factored down anymore. Once again, it does not follow the formula because it doesn't have a negative. It has a positive, so we cannot use the difference of squares formula. Okay, so sorting it all out, last thing I want to talk about with you today, we're going to factor these just using what we know about factoring so far. So if we're looking at part A, I have 4x squared y minus 20xy squared plus 12xy. I'm going to look for my GCF first. So let's go ahead and see what is the largest coefficient and the largest exponent that I can pull out of all three of those terms. Well, if I take a look here, I have 4, negative 20, and 12. I can pull a 4 out of each of those easily. And then what are some of the variables and exponents I can pull out? Well, if I look here, I have x squared, x, and x. So obviously I can pull out an x. And then I also have y, y squared, and y. So I can pull out a y. So if I pull out 4xy from each of these terms, here's what's going to happen. 4x squared y divided by 4xy, well, 4 is going to go away, right? 4 cancels. X is going to cancel with x squared, so we're just going to be left with x. And then y's are going to cancel. So I'm just left with x, okay? So it's a little lonely now. And then I'm subtracting 20xy. So if I take 20xy divided, or excuse me, 20xy squared divided by 4xy, well, I know that 20 divided by 4 is going to give me 5. And then x divided by x is just going to be 1, so that's going to cancel out. Y squared divided by y is just going to be y. And then last but not least, 12xy divided by 4xy, 12 divided by 4 is plus 3. X divided by x and y divided by y are just 1. So I have pulled out my GCF, and that is going to be final factored form. Obviously, this does not follow the structure that we need in order to factor using the diamond method, so we're going to go ahead and move on. All right, next one, B. We have m cubed minus 9m squared minus 10m. First of all, do I have a GCF here? Absolutely. I have an m that's in common with all of these terms, okay? So I can pull those m's out. So if I pull an m out here, here's what's going to be left over. M cubed divided by m is just m squared. Negative 9m squared divided by m is negative 9m. Negative 10m divided by m is just negative 10. Now I can try to factor this using the diamond. So on the top, I'm going to put my a times c value. On the bottom, I'm going to put my b. So at the end, I have negative 10 and then negative 9. Factors of negative 10 that add up to negative 9. Well, if I do negative 10 times 1, that's going to multiply to negative 10 and add up to negative 9. So I'm going to drag and drop those inside. I have m times m minus 10 times m plus 1. Again, I am dragging and dropping those factors inside. Moving down to part C, I have 2x cubed plus 11x minus 5. I noticed that I can't factor anything out here, so I'm just going to go straight into using my diamond. So on the top, I have a times c. On the bottom, I have b. A times c, obviously here we have something that's not 1, so a times c is negative 10. And then b is positive 11. So factors of negative 10 that add up to 11. Well, if I think about this, I can't think of any factors of negative 10 that add up to 11 because I have, let me think here. I got negative 10 and positive 1. That's going to be negative 9 if we add those up. Then we have negative 2 and positive 5. That's going to be 3. Negative 5 and positive 2. That's still negative 3. So obviously, I see a trend here. These are not adding up. Okay, so this is going to be prime. Once again, if you simply cannot find factors, chances are it's going to be prime unless you're making some sort of mathematical error. But most likely, it's probably prime if you can't find those factors. Last but not least, we have 2x to the fourth minus 32y squared. First things first, let's go ahead and pull out a GCF. I always want to look for those GCFs first. So my GCF here, I obviously can pull out a 2 from both of those terms. So if I pull out a 2, I'm going to be left with x to the fourth minus 32 divided by 2 is 16y squared. And then, do I notice something about this? This is a perfect square. This is a perfect square, and I'm taking the difference of them. So I have the difference of perfect squares, so I can use this formula, a plus b times a minus b. So what I'm noticing here is that this is a squared minus b squared. So if I take the square root of that a squared term, I know that a is going to equal the square root of x to the fourth is x squared. Then if I take the square root of b squared, that's going to be the square root of 16 is 4. The square root of y squared is y. So that's 4y. And now I can plug that in using the formula. So I have to keep the 2 out front. And then I have x squared plus 4y. That's a plus b. Times x squared minus 4y. That's a minus b. So my final answer is 2x squared plus 4y times x squared minus 4y. All right, ladies and gentlemen, that is how you factor. Please make sure you look back over this video if you need additional help. Otherwise, I will see you back here next time. Thank you.